Let's prove an interesting algebraic identity involving trigonometric powers. We are going to show that sine to the sixth power of theta plus cosine to the sixth power of theta is equal to 3 times sine to the fourth power of theta minus 3 times sine squared theta plus 1. We begin with the left-hand side of the equation, sine to the power of 6 theta plus cosine to the power of 6 theta. This is a standard sum of cubes form, so we use the identity that says a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. In our case, a is sine squared theta and b is cosine squared theta. So expression become sine squared theta plus cosine squared theta times sine to the fourth power of theta minus sine squared theta cosine squared theta plus cosine to the fourth theta. Now sine squared theta plus cosine squared theta equals 1. So the first part becomes 1. We're left with sine to the fourth theta plus cosine to the fourth theta minus sine squared theta times cosine squared theta. Now let's simplify this expression. We know that sine to the fourth theta plus cosine to the fourth theta can be written as sine squared theta plus cosine squared theta squared minus 2 times sine squared theta times cosine squared theta. Since sine squared theta plus cosine squared theta is 1, this part becomes 1 squared, which is just 1. So now we have 1 minus 3 times sine squared theta times cosine squared theta. Now recall that cosine squared theta is equal to 1 minus sine squared theta. So we substitute that into the expression. 1 minus 3 times sine squared theta multiplied by 1 minus sine squared theta. Multiplying that out gives us 1 minus 3 times sin squared theta plus 3 times sine to the fourth power of theta. Now rearrange the term 3 times sine to the fourth theta minus 3 times sine squared theta plus 1. And that exactly matches the right-hand side of the identity. So, identity proven.